I'm going to solve chemistry paper 2 AS level May June 2023 2 variant. Let's get started. Question number 1, melting point of some solids are shown in table 1.1: magnesium, phosphorus, sodium chloride, sulfur. A part 1 states the type of bonding present in magnesium and sodium chloride. As you know, magnesium is a metal, so the bonding in magnesium is metallic bonding. Bonding in sodium chloride, basically that is ionic bonding. Ionic bonding, as there are metal and non-metal. Moreover, it is also having high melting point. Next question, part 2, explain the difference in the melting point of magnesium and sodium chloride. The basic difference is the difference of bonding. So, ionic bonds are stronger than metallic bonds. So more heat is required. More heat is required to overcome the forces and so on, or just more heat is required. Part 3. Explain the difference in the melting point of phosphorus and sulfur in terms of structure and bonding. You know the formula of phosphorus is P4 and formula of sulfur is S8. Sulfur is having more number of atoms in its molecule than phosphorus, and these both are said to be simple covalent molecules. It means that sulfur is having more number of electrons. So S8 has more number of electrons than phosphorus, that is P4. So it has stronger temporary dipole dash induced dipole forces than that of P4. So that's why its melting point is higher. Its melting point, the melting point of is higher than P4. Part B, define electronegativity. It's the power of an atom to attract shared pair of electron towards itself. Second part, why electronegativity increases across the period. The reason is quite similar as that of the reason for the trend of ionization energy. So number one, size of atom decreases. Number of shell remains same. number of shells remains same. The next thing is nuclear charge increases, so attraction of nucleus increases. So attraction of nucleus increases on outer electron, on outer shell electrons, and so on. The next one. Name the strongest intermolecular force that exists between NH3 molecule, that is hydrogen bonding. Draw a diagram to show the formation of strongest intermolecular force between two molecule of NH3. Here is one NH3, NH3. It's a lone pair, partial negative, partial positive, partial positive, partial positive. And I'm going to draw another NH3, or you can see similar drawing should be there. So there must be another NH3, you can say like that. This is one NH3, I mean. We can draw like that, and that is the other NH3. NH3. So one bond will be over here, other bond will be over here. These are not the very much true bond basically. The bond angle is not true. This bond angle must be more than 85 degree, and that is almost, I mean, actually it should be 180 degree bond angle or slightly less than 180. So the Marx division is like that. There must be the lone pair on nitrogen atom and partial positive charge on hydrogen atom. Same is the case on the other molecule, one lone pair and partial positive charge on the hydrogen atom. Then there is attraction between the lone pair and the partial positive hydrogen atom, that is said to be the hydrogen bonding. The next one. The melting point of the ice and ammonia are shown in table 1.2. Ice, ammonia, both are having the melting points over here. Suggest two reasons why the difference in the melting point of the ice and ammonia. Number one, ice is having more and strong hydrogen bond. Strong hydrogen bonding. More and stronger hydrogen bonding. Why is this so? The reason is strong hydrogen bonding, then ammonia. The basic reason is ice is having, or one molecule of ice, you can say, one molecule of ice has two combination of partial H positive ion. For H positive ion, partial H positive ion, I mean, partial H positive ion and lone pair, So basically, the first thing is ice is having more and strong hydrogen bonding than ammonia in its sample. One molecule of ice is having two combination of perfect combination of partial positive hydrogen and the lone pair. But in case of ammonia, I mean NH3, ammonia is having just one combination of, as you have seen in the first portion of this question, just one combination of this pair. I mean the combination of partial hydrogen and lone pair. So ammonia is making two bonds and ice is making four hydrogen bonds. So more hydrogen bonding is lying over here, more hydrogen bonds and strong hydrogen bonds. As compared to ammonia, ammonia is making less hydrogen bond, just two hydrogen bond. Molecule of the water is going to make four hydrogen bonds. Come toward the next question, question number 2. It's from period 3 elements, I think. Question 2. Chlorine is a reactive element. It forms many compounds. Complete table 2.1 shows the maximum oxidation number of the elements sodium 2 phosphorus in their chlorides, and maximum oxidation state is +1. Oxidation number is +2, and for aluminium +3, for silicon +4, plus for phosphorus +5. State what determine the maximum oxidation number of elements in period 3. Basically, outer shell number of outer shell electrons determine oxidation states, maximum oxidation state. Maximum oxidation state is because of the total number of electrons present in the last shell. B. An excess of the cold water is added to the chloride of silicon. Write an equation for the reaction between excess cold water and chloride of silicon. SiCl4 is the chloride of silicon plus H2O. This is a liquid water, cold water. It's going to make SiO2, silicon dioxide, and HCl. 4 mole of HCl will be there, and so 2 should be over here, and this is the balance equation. Suggest the pH of the solution formed in B1. This one. This is not water soluble, just HCl is water soluble. So you can write 2 or 3. 2 or 3. An excess of cold water is added to the chloride of phosphorus. Write an equation for the reaction between the excess of cold water and the chloride of phosphorus. Chloride of phosphorus, there are two chlorides, PCl3 and PCl5. PCl5 and plus H2O goes to H3PO4 plus HCl. For the sake of balancing, I'm going to put 2 over here and HCl going to put 5 over here. In case of PCl5, 5 should be there, and 4 over here, just for the sake of balancing the equation. And hydrogen is balanced, C, everything is balanced now. Suggest the pH of the solution produced in this reaction C1. Both are acids, so pH is equal to 2, 1 or 2. Write an equation for the reaction of chlorine with water. When chlorine is allowed to react with H2O, it makes two acids. Number 1 HCl, number 2 HClO. And this is the balance equation. Yes. Write an equation for the reaction of chlorine with hot NaOH. Cl2 plus NaOH goes to. With hot NaOH, number 1, NaCl is formed, number 2, NaClO3 is formed, plus H2O is formed. So basically, how to balance this equation? I think 5 over here, 6 over here, and 3 over here, and 3 over here. I think this equation is the balanced equation. Yes, it's balanced. Bleach is used as a cleaning product to kill bacteria. It is made by adding compounds like sodium chlorate to the water. Identify the formula of the ion present in the bleach that kills bacteria. That is ClO1 negative ion. ClO1 negative ion is the ion that is basically responsible for killing the bacteria. Sodium chlorate react with hydrogen peroxide to produce sodium chloride. Water and oxygen construct the equation. So NaClO plus H2O2 goes to NaCl, H2O, and oxygen. So let me balance this equation. Overall, 3 oxygens are there, 2 hydrogens are there, 3 oxygens are there, 1 NaCl, and it's a balance equation. A sample of bleach W contains unknown concentration of sodium chlorate. This is the sodium chlorate. 10 centimeter cube of the W is diluted with the distilled water to make total volume of 100 centimeter cube of bleach solution. So first of all, we are making 10 ml or 10 centimeter cube solution into 100 centimeter cube solution, and from where we are taking 25 centimeter cube of this dilute solution. This solution is added to the excess of hydrogen peroxide, and the volume of the gas produced. There is only one gas at room temperature, that is oxygen, under room conditions. The experiment is repeated, and on average 25 centimeter cube of the dilute bleach solution produces 42 centimeter cube of gas. Calculate the concentration in gram per dm cube of sodium chlorate 1 in W. First of all, I'm starting from this information. We are having the volume of oxygen. Oxygen is equal to 42 centimeter cube. I'm going to find the mole of oxygen. So 42 divided by 1000, 24,000. That is equal to the number of moles. So 42 and divided by 24,000, the answer is 0.00175 moles. So basically, these are the number of moles of oxygen that is being formed at the moment in this reaction. First of all, you can see in this balanced chemical equation, what is the mole ratio of oxygen and mole ratio of NaClO? 1:1. So once again, it will be equal to 1 mole. The same mole of NaCl will be there. NaClO will be there. NaClO is also equal to 0.00175 moles of NaClO in 25 centimeter cube bleach. Basically, we have taken this 25 centimeter cube from 100 centimeter cube. So NaClO in 100 centimeter cube is equal to 0.00175 multiplied by 4, as 100 centimeter cube is 4 times bigger than that of 25 centimeter cube. So multiply by 4, and the answer is 0.007. So 0.007 moles of NaClO is there in 100 centimeter cube. Now going back, actually that 100 was having 10 centimeter cube. So the 10 centimeter cube of NaClO3 is also having 0.007 moles. Now we have reached to the number of mole of NaClO in 10 centimeter cube. In 10 centimeter cube. Now it's time to convert into 1000, as he is asking to find the gram with respect to dm cube. 1 dm cube is equal to 1000 centimeter cube. So 10 centimeter cube is having mole that is equal to 0.007. What about if I'm using 1000 centimeter cube of W? Then it will be 0.007 over 10 into 1000, and it will be equal to 0.007 multiplied by 100, that is equal to 0.7. So that is equal to 0.7. Once again, let me check the original options and answer. First of all, from the very beginning, 42 and divided by 24,000, that is 0.00175 mole. Yes, it is correct. And then multiply by 4, that is equal to 0.007. Yes, it is true. And these are the moles in 100 centimeter cube. Same moles will be in 10 centimeter cube, because there is no addition of any other NaClO, just we make 10 to 100 by adding the water. So we just add water. By the addition of water, there is no change in the moles. And finally, if the 10 centimeter cube is having this one, then multiply by 1000 and divide by 10, and yes, it's 0.7. So correct. So we are having finally 0.7 mole of NaClO. What is the mass of NaClO? We are having the mole of NaClO in 1 dm cube. And what is the mass basically? What is the mass? We are going to find the mass, this grams, and we are having its MR 23 plus 35.5 plus oxygen is equal to 16. So 23 plus 35.5 plus 16, and that is equal to 74.5. and you know mole is equal to mass over mr, and mr is equal to 74.5, mole is equal to 0.7. What will be the mass? Mass will be equal to 0.7 multiplied by 74.5. And the answer is 52.15 grams per dm cube. This is the final answer. Question number 3, this is regarding organic chemistry. Figure 3.1 describes the sequence of reaction that can be used to produce food additives compound Y from this haloethane, chloroethane. Step 1, step 2, step 3. In step 1, the Cl is being replaced by a CN group. In step 2, the CN group has been changed into carboxylic acid. And finally, we are adding calcium, strong, more reactive metal, the more reactive than hydrogen, and here is the Y. A part 1 state the reagent and condition for the step 1. In step 1, whenever you are going to substitute the halogen by the CN, so we will have to use KCN or NaCN in alcoholic solvent, plus condition is heat. Give the systematic name of X. Here is the X, and it is having 3 carbon and nitrile group. 1, 2, 3. Very simple. It is having 3 carbon. Its name will start from prop. Carbon, carbon are single bonds. So ene, and because of its functional group, it is said to be nitrile. So propene nitrile. It's propene nitrile. Identify the type of reaction that occurs when the dilute acid is added to X in step 2. Identify the type of reaction when acid is added in X step 2. I mean, how to make this CN group into, or how to change this CN group into acidic carboxylic acid. It is said to be hydrolysis or acidic hydrolysis. Hydrolysis, or you can say the acidic hydrolysis. In step 3, Y and a gas are produced. Construct the equation for step 3. So I'm going to make its condensed formula, molecular formula, that is having 3 carbon. How many hydrogens are there? 6 hydrogen and 2 oxygens are there. And plus calcium goes to, it will make hydrogen gas, and there will be C3H 5 or 1 less hydrogen, and we will have to use 2 mole of this one, 5O2 twice calcium. And this is the balanced chemical equation. Yes. B part, this ethanoic acid can also be formed from propane 1 mole and potassium dichromate. Set the condition. Potassium dichromate should be in acidified condition, acidified acid solvent. I mean, the next one is heat under reflux. Heat under reflux are the condition. Complete the table 3.1 to show the number of sigma bond and pi bond present in molecule of X. So this is the molecule of X, propane nitrile, and I am going to write it like that. And these simple lines are the sigma bonds and pi bonds. There is only one pi bond. This is the pi bond, and all these where I'm placing tick over here, these all are said to be the sigma bonds. Single bonds are sigma bond. Multiple bond is having one pi bond. So pi bond is equal to 1, and sigma bond 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 sigma bonds are lying over here. I mean 4 plus 3 plus 2, 9. Yes. Question number 4. In industry, ethanol is made reacting ethene with the steam in the presence of H3PO4. Reaction 1. And here is the energy table. He is asking to find the enthalpy change R for this reaction 1. Basically, it is necessary to write the displayed formula. C2H4 plus HOH goes to ethanol. Ethanol, you know, that is the displayed formula of ethanol. And nothing else. Yes, it is an addition reaction. Some bonds are common on both sides, so I'm going to basically delete these bonds. One CH bond over here, one CH bond from 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 here, and one CH bond from here, again one CH bond from here. And the second common bond is that is lying over here is one OH bond over here and one OH bond over here. So these are the basically different bonds. Those are bringing the chemical change. C double bond C 610 plus OH bond, that is 460. These are the total bond energy of the reactant, minus CH bond, that is 410, this one 410, plus one is C single bond, C 350, and one is C single bond O, that is 360, and that whole is equal to delta H. So let me check, or let me calculate the answer. 1070 minus, that is equal to 1120. So I mean 1120 and 1070 minus 50 minus 50. So the answer is minus 50 kilojoules per. Reaction 1 reaches equilibrium at constant temperature and pressure. Deduce what effect increasing the pressure will have on the amount of ethanol in new equilibrium mixture. Use Le Chatelier principle to explain your answer. So at that time, we are going to increase the pressure. The increase in pressure is going to have the effect on the position of equilibrium if there are different number of mole of the gases. So the 2 mole of the gases are lying over here, 1 mole is over here on the right hand side. So increase in pressure, equilibrium will be shifted toward the right hand side. So effect on increasing the pressure, more alcohol, more ethanol will be formed. Ethanol will form. Why? I mean, less number of moles are lying on the right hand side. Less mole of gases are on right hand side. High pressure favor the less number of mole. High pressure or increase in pressure favors side of less number of mole. The next question, part C. The mechanism for reaction 1 can be described in 3 steps. Step 1 and step 2 for reaction 1 are shown over here. Step 1 is the double bond is going to approach this phosphoric acid, and in step 2 there is a combination or the reaction between water molecule and the carbocation. Describe the behavior of H3PO4 in step 1. He is asking just in step 1, and this is under attack by these pi bonds, pi electrons. So this is acting as electrophile. It's behaving as electrophile. This is behaving as electrophile in step number 1, as it is reacting with the carbon-carbon double bond. Identify the species that behave as an electrophile in step 2. In step 2, this is the electrophile, electron lovers, that is having full-fledged positive ion. I mean, that is ethyl positive ion. CH3, CH positive ion, CH2 positive ion. I mean, ethyl positive ion. The next one thing is complete figure 4.2 to show the mechanism for step 3 for reaction 1. Include charges, dipoles, lone pair of electron and curly arrows as appropriate. In this case, you can see that it is having an oxonium ion, and this is the negative charge. I mean, it's the base basically. This reaction is in fact, this is acting as a base. So it will abstract this hydrogen, and this bond will be shifted towards oxygen atom to make a normal neutral alcohol and phosphoric acid back. So this is the you can say the mechanism, like the elimination mechanism, and this negative charge will attack on the hydrogen atom, and hydrogen will leave its bond towards the oxygen, and I mean this OH bond will be shifted towards oxygen, and there is the formation of neutral molecule. So here's the mechanism. Describe how a catalyst affect a reaction. Is for 2 marks. Number 1, it lowers energy of activation. Number two, more particles more particles have energy more than energy of activation, so they can cross the barrier and speed is enhanced. The second thing is the major thing is how catalyst affect the rate of reaction. It lowers energy of activation, more particle, and hence the rate of reaction is increased. Rate increases. So that is a complete response. Use figure 4.1 and 4.2 to justify H3PO4 is described as a catalyst in the reaction 1. So in reaction 1, basically that is having three steps, and yes, it is basically uh, in taking part in reaction initially, but remain unchanged finally. So it is acting as a catalyst. 4. Propene also reacts with steam. A mixture of organic product is produced. Why propane 2-ol is produced in higher yield? Basically, when propene is allowed to react, and this is the propene. Here, two type of carbocation is formed. One carbocation may be formed on this carbon atom, and other one on this carbon atom. So, when the carbocation is formed on this ending carbon, that is said to be the primary carbocation, and if the carbocation is formed on the middle carbon, that is said to be secondary carbocation. Propane 2-ol, this is carbon number 2. So propane 2-ol is formed from or via secondary carbocation. Propane 2-ol is formed via secondary carbocation. It's formed by a secondary carbocation, and secondary carbocation is more stable than primary carbocation. Primary, because of inductive effect, because of inductive effect of methyl groups, or in this case you can write two methyl groups. So that is a sufficient answer. Question number D. Describe the covalent bond present between carbon atom and ethene molecule by completing table 4.2, just between the carbon atom. This is the structure of ethene basically. And here is the pi bond, another one is sigma bond. And basically, mainly you can say, not basically, this carbon is sp2 hybrid. This carbon is also sp2 hybrid carbon. So when sp2 hybrid carbons meet together, overlap together, there is a formation of sigma bond in this case, and pi bond is formed due to the overlapping of p orbitals. So the orbitals involved in bonding, sigma bond sp2 orbitals, in pi bond p orbitals. sp2 orbitals overlap head to head overlapping, and the pi orbitals overlap sidewise or parallel overlapping. Question number 5, describe structural isomerism. Molecules having same molecular formula but different structure formula, different arrangement of the atoms or different structural formula. And different names, IUPAC names you can say. Basic definition is molecule having the same molecular formula but different arrangement of the atoms or different structure formula is said to be the structural isomerism. A and B are the structural isomers with molecular formula C5H10O. They are both straight chain molecule with only one functional group. Table 5.1 describes observation when the separate sample of A and B are added to the different reagents. The first one is 2,4-DNPH, orange precipitate appears. It means that A and B may be the aldehyde or the ketones. Reagents, Tollens reagent, silver mirror is formed, that is an aldehyde. It means no reaction, so it means that this B is ketone. A is aldehyde and B is ketone. Alkaline aqueous iodine, no reaction. This means that these both compounds A and B, none of them is having this CH3C double bond O group. No one is having this group. Name the functional group present both A and B. So the collective functional group for aldehyde and ketone is carbonyl. So collectively it's known as carbonyl. Carbonyl. It's the name of functional group. Draw the structure of A and B in the boxes. Number 1, A is having 5 carbon, straight chain carbon. All carbons are lying in a straight chain molecules and only one functional group. And A and B. A is aldehyde, C double bond OH, and 1, 2, 3, 4, and 5. So CH3, CH2, CH2, CH2. This is a possibility for the A is it should be an aldehyde. The ketone, the possible ketone, it may be this one, C double bond O, CH2. At least more than one carbon should be present on its either side, because it is, as we have seen, that it's not going to give the iodoform test positive, so it cannot be this one ketone. See the structural isomers of A and B. C is straight chained and has 2 functional groups. C show only one type of stereoisomerism. Table 5.2 describes the observation when separate sample of C are added to the different reagents. 2,4-DNPH, no reaction, I mean it's not an aldehyde or ketone. Reaction with bromine, orange to colorless, mean it is having carbon-carbon double bond, at least one carbon-carbon double bond. And alkaline aqueous iodine, yes, it is reacting it and making yellow precipitates or yellow appearance. So what is the C basically? C, that is having the 5 carbon and 10 hydrogen, 1 oxygen, but it is having one carbon-carbon double bond and no any sort of aldehyde and ketone. So first of all, I'm going to write a carbon-carbon-carbon double bond over here. And it is showing this isomerism, one type of stereoisomerism, so it may be the cis-trans isomerism. So CH3 over here, H over here, and H over here, and 1, 2, 3 carbons, and CH2, CH3, and I'm going to make an alcohol that will give the iodoform test positive, that is this one. So this is the methyl alcohol, and it will give this alkaline iodine aqueous test positive. So this is showing the cis-trans isomerism. Yes, it is true. 1, 2, 1, 2, 3, 4, 5 carbons atoms are there. Yes, it is true. How many hydrogens are over here? 3, 4, 5, 6, 7, 8, 9, and 10. Yes, it is true. So this is the C. Name the type of stereoisomerism shown by the molecule C, that is called geometric or cis-trans isomerism. Part D reacts in the presence of sulfuric acid to form E and water. The structure of E is shown over here. Name the functional group present in E, that is the ester. It is an ester, cyclic ester, right? Just ester. Identify the type of reaction that occurs when D reacts to form E. Identify the type of reaction when D reacts to make E, that is said to be condensation. Draw the structure of D in the box, and what should be the D? I'm going to do it in a reverse way. I mean, if I'm going to hydrolyze this molecule E, it will be changed into D, acidic hydrolysis, I mean. So this bond is broken down, and here OH, and there will again be OH. This is D. So this is D. Oh, 1, 2, 3, 4. Yes. 5. 1, 2, 3, 4, 5. 5. Yes. OH. And here must be an OH group. Part 4, IR spectrum of the E is shown over here. And there are basically these major peaks. Here are the major peaks. Main peaks, I mean. And the table is given over here. Use figure 5.2 and the table 5.3. This is the 5.2 and table is 5.3 to predict two differences in absorption of 150 centimeter of IR spectrum of D compared to E. 150 above 1500 per centimeter. So in case of D, there must be the peak, a huge peak that should be present over here in this region, I mean. So OH peak is missing. In case of D, OH peak should be there, that is lying in this range 2500 per centimeter to 3600 centimeter. That is missing in D, that is not in E. And the second thing in E we are having basically no peak that is present over here, and this is ester. C double bond O is the common, CO bond is common, so these two are the common peak. Rest of the all peaks are common. OH peak and D, there's OH peak should be over here, and no peak at 2500 to 3600. So basically, as far as the two differences is concerned, in D this peak will be present. In peak there is no broad peak, I mean no broad peak or very broad peak. But here is the, you can see the weak signals of this CH3 group. In E, weak signals are over here, weak peak is over here. That may be because of CH bond. Weak signal for CH bond is lying over here. That's all. Thank you.